what it could look like. See if this makes sense with what you were thinking, and hopefully this will all tie together. So first of all, we want to go to standard form, so that would be 6x to the third minus 11x squared minus 7x is equal to 0. You just subtract that 7x over and get to that standard form. And then I think you guys did a nice job of noticing that there's a common x as far as the GCF, and you factor that out. And so x parentheses 6x squared minus 11x minus 7 equals 0. So my advice to you on something like this, knowing that that trinomial might, I'm sorry, that x is kind of off the edge there. Knowing that that trinomial might factor as well, my advice to you would be to take that x that we just factored out and just continue that on down and realize that that's going to be part of our factoring, but I'm not going to really do anything with it while I work on the trinomial because I feel like it could be confusing. So what I'm going to do now is just work on the trinomial only. My AC for this one would be negative 42. The B was negative 11. And finding the two numbers that work was kind of tough, wasn't it? There was a lot of like, man, is this prime? I don't know if this works. So you guys kept on kind of fighting through it, and obviously some folks came up with it, and eventually I think just about everybody came up with negative 14 and 3 were the two numbers that worked here. So when you do that, you end up with 6x squared minus 14x plus 3x minus 7. You group the first two, you group the second two, and you add the two groupings. You guys did a good job factoring everything out. Bless you. So 2x is the GCF here, 3x minus 7 right there. And I would just take a 1 out because the leftovers already match. So we get to here, and we could finally say 3x minus 7 times the leftovers of 2x plus 1. And we get something like that. Now here's where you'd want to remember that, oh yeah, this x that I factored out at the start is actually part of the factoring. Okay, equals 0. And that would be, should be the factoring there. Question?
Wait, is the thing on the bottom of the x a negative 9 or 11?
The thing on the bottom, oh sorry, this right here, it's a negative 11.
Oh, okay.
My pen kind of got a little overzealous. Okay. So, like I said, this was kind of the stage where just about everybody got to eventually, and they're like, hey, I got this thing factored, but what do I do with this extra x right here? I would say you treat it just like the other two factors, right? So if you've got a product of 0, you've got several factors, in this case 3, what you do is you use that 0 factor property, and you set each of the 3 factors equal to 0. So I'd set the first one equal to 0, and that actually is one of the answers, isn't it? Just x equals 0. And then you set the other two factors equal to 0, like 3x minus 7. For that one, you end up with x is equal to positive 7/3 when you add 7 and divide by 3. And then the other one, you'd go 2x plus 1 equal to 0. You end up with x is equal to negative 1/2. So you get 3 answers. I was sharing with some of the folks at the back there. You'll learn in Algebra 2 that if you have a third-degree polynomial like this one, 6x cubed, you'll potentially get 3 different answers. If you have like a 5th-degree polynomial, you'd potentially get 5 different answers. So it's a fundamental theorem of algebra. You'll learn that in Algebra 2. Yes, ma'am?
If the, like, let's say like the number we factored out was like a 3 or something.
Sure.
Would it just say like 3 equals 0?
Is that true?
I don't know.
Does 3 equal 0?
No.
It doesn't. It doesn't. So that's a great question. Does anybody have any follow-ups on this one before I address that? I was going to just erase all this.
What is it?
Okay. So Sarah, and this will probably be good for everybody. Let's say we're talking about a whole different question here. So let's just scratch this out for a second. Let's say we had some factoring. Let's say that it was like 3 times x minus 2, x plus 5, or something like that equals 0. Like, how would you handle the 3? You know, of course, with the x plus 5, you'd do this. The x minus 2, you'd do this. But then would you go 3 equals 0 and say, hey, 3 is one of my solutions? You wouldn't, because 3 simply does not equal 0. And so that's not going to yield anything useful to us. This one will. We'll get x equals 2. This one will give us x equals negative 5. But 3 simply does not equal 0. So it's just not part of a solution.
Oh, okay.
Yeah. So we'd just ignore that part for that reason. Great question. Anybody else? Okay. How'd the video go for you guys? We got up to about 90-something%. We just about had everybody do that. And then a lot of you guys got the check for understanding right. Let me ask you this. Watching the video, knowing how we're going to finish.
There wasn't a check for understanding.
Oh, there wasn't? Sorry. You watched the video, though.
Yeah.
That's good. So watching the example in the video, sorry, I'm mixing you up with one of my other classes, I guess. Watching the video, did you guys see how the basic mechanics of everything we're going to do today is essentially the same thing we did yesterday, which is essentially the same thing we did the day before that, and the day before that, and the day before that? It's all about factoring, right, if you wanted to boil it down to one thing. So I hope that makes sense to you. We're going to jump into it right now. I've got a handful of examples. I think we should be in pretty good shape. So grab your Chapter 6 notes, and we will go there. We're going to skip around a little bit. We might come back to number 2, but I definitely want to do this one. I want to do number 3, and then I'll have you try number 4 with a partner just at your table there. So this is where printing the notes out, as you can see. This comes in kind of handy here. This is kind of a long question to try to scratch out real quick while we get going with it. So let me do a little better job of this. There we go. Okay, so this is a classic application. If you ever take a physics class, you will work on stuff like this. This is kind of a good warm-up for a class like that. So it says a pitcher can throw a fastball at 79 feet per second if he throws the ball into the air. And I would say something like, just to be specific here, for this to work out, he'd have to throw the ball basically straight up into the air. So if he throws the ball straight into the air with that velocity, its height, h. Let me ask you this. The way this is worded, does this make sense? Its height, h. Do you know what that means?
Like H is
Yeah, h stands for height, right? And then t seconds after being released, that means t stands for time in seconds, right? So I just want to make sure that that's clear. I'm sure it probably is, but I just want to make sure. Okay, so the height is approximated by h equals negative 16t squared plus 79t plus 5. This is actually a very realistic equation. We are neglecting air resistance, but assuming the ball is fairly smooth, it's not too bad. Okay, so this says, after the ball is thrown, in how many seconds will the ball hit the ground? So we need to brainstorm a little bit here and think about what that phrase means, hit the ground. What does that mean for this situation, for this equation? The equation stands for height in terms of time. The ball's going to hit the ground. Obviously, we know if you throw something up, it's going to come back down and hit the ground eventually. What do you think that phrase, hit the ground, would mean?
Get to 0.
What's 0?
The height.
The height. That's it, isn't it? The height would be 0. So if the ball hits the ground, that means that height is 0. This is a really key point that we want to, if we're looking at some question like this and we see, somebody throwing a ball, or like number 4, shooting an arrow, we know that unless somebody catches it, it's going to hit the ground, right? And so the act of hitting the ground means that its height has gone from whatever it was to 0, because we'd count the ground as like the baseline 0 height. So if I was going to solve this, I want to know in how many seconds the ball will hit the ground, and how many seconds is a time reference. And I know that hit the ground means h equals 0. What I would do is take this equation right here, and I would make h 0, right? I'd make h 0 means the ball just hit the ground. So I would write 0 equals negative 16t squared plus 79t plus 5. So I'd encourage you to think about this in terms of what we've been doing. Is this not what we did yesterday and what you just did 10 minutes ago? It's the same sort of question. The only thing we've done, I've contextualized it a little bit by saying, hey, this is a ball thrown into the air. This is what we call a kinematic equation, legitimately a physics equation that actually shows the height of the ball. And we can now set h equal to 0 because the ball is hitting the ground. We can now find the time. So there's going to be a few little tricky things we need to navigate, but the main thing we need to do is factor. You guys just showed you're pretty good at it. So work on your own, or maybe work together a little bit if you want. See if you can factor this. Use the zero factor property and perhaps solve it. We'll talk about the meaning of the answers and how it all works together, but please give it a shot. Numbers are kind of large. Use a calculator. You can do it. You guys are doing well. You're doing really well with this. Once we get to this nice standard form, we'd use our Magic X. Now, please pay really close attention, because on this next one, with the arrow that's coming up, I want to see if you can just do it all by yourselves. We'll see. So pay close attention. If you have questions, let me know. So this is a standard form quadratic, so we're going to use the x to kind of break it down and help us understand what to do. The AC would be negative 80. The B is positive 79. So we got to ask ourselves which two numbers multiply to be negative 80 and add to be 79. And you guys came up with this one pretty quick. Isn't it positive 80 and negative 1? Positive 80 and negative 1. Okay. So then what we're going to do is split up the B according to that. So 0 equals, and it's going to be negative 16t squared plus 80t minus 1t plus 5. There we go. And we group the first two, and we group the second two, and we add the two groupings. Is this feeling like extremely familiar at this point? We've done this a lot. We just need to keep practicing, and hopefully I'm shooting for 100% accuracy. I'm hoping that you guys are there with me on that. Okay, so then we factor out the GCF. You could go either way here. You could factor out in the first grouping, you could factor out a 16t, or you could factor out a negative 16t. It really doesn't matter. I think I'll factor out a negative 16t, but you can go either way. So if I do this, I get negative 16t. My leftovers would be t minus 5. And then I look at the other one and I say, okay, do I need to factor anything out of that? And the truth is, if I want the leftovers to match, I do need to factor out a negative 1. So if I factor out a negative 1, I end up with positive t minus 5. My final factoring would be 0 equals t minus 5 times negative 16t minus 1 with my leftovers right there. Does that make sense, Kenzie? Something wrong? I think we're going to end up with the same answers because I factored out a negative and maybe you didn't, and the ordering could be a little bit different. We could look a little bit different at this stage, but now when I set each factor equal to 0 and solve, I get t is equal to 5. And then over here I set negative 16t minus 1 equal to 0. And solve here I get t equals negative 1/16. So at this stage we should agree. So let's talk about these two answers because we did get two of them, not surprisingly. One of the answers works and we would absolutely accept it as being a plausible answer. The other one we would not accept. Which one would we not accept? The negative one, yeah. So negative time, let's think about what this means. People will often say you can't have negative time. And I sort of agree with that, but I also would say, isn't negative time referring to like a time previous to some other time? You know, so like negative 5 hours ago, you were like just showing up to school. That makes sense? So, but think about what this means for this guy with the baseball, this pitcher with the baseball. Maybe it's a girl, I don't know. This person throws the ball in the air, and negative 1/16 would be saying this. Like if you said that was the time, you'd basically be saying that if you throw the ball up into the air, it'll hit the ground a 1/16 of a second before you threw it. That makes no sense, right? It doesn't make any sense at all. You need to release the ball for it to come down and actually hit the ground. And 1/16 of a second before you threw it, it's probably still in your hand. Like, there is actually a reason that this answer shows up. It's not that ridiculous, but for the context of the situation, it is ridiculous. And so we would just go with a final answer of t equals 5 seconds. There would just be the one answer that's valid here, and we'd leave it at that. Go ahead, Morgan.
If you had two positive answers,
Good question. I don't think that would happen. If you did things right, you should get, if you get two answers in these scenarios, you would either get a negative and a positive or 0 and a positive, and you'd always would pick the positive one because that's into the future somewhere, and that would make sense. Cool. Keely.
If we had the negative 16th on a test, would you count it wrong?
So yeah, so let's say this was, I don't know, let's just make it up. Say it's a 5-point question. I'd probably give you 4.5 out of 5, simply because you got to answer within the context of the question, and just the negative time doesn't make a lot of sense. But you'd get 90% of the credit simply because you've done a lot of good work, a lot of really good work. Question, Sarah?
You just delete it?
I drew an X through it. You could,
Yeah, again.
that's just as effective. Scratch it out, something, that's fine. Okay, so let's see how you do with this one. Number 4, try this by yourselves or with a table partner if you want. It is very similar to what you just did, so hopefully this will go for you. This time it's an arrow instead of a ball. Similar looking equation, and the arrow will be hitting the ground. So, of course, t squared plus 77t plus 15. And so that's a good start, right? You want to set the h equal to 0. Once you've done this, then we want to do our x and our split the b method. So in a situation like this, our AC was negative 240, our b was 77, and it's pretty big numbers, right? So if you use your calculator, start doing some dividing and multiplying. I saw that most of you figured this out. It's 80 and negative 3, right? 80 and negative 3. So once you get to that stage, you can then split the b. So 0 equals negative 16t squared plus 80t minus 3t plus 15. You group the first two, you group the second two, and you add. Question?
Oh, crap. I did it wrong. Never mind. Well, because I had it as negative 80 plus 3, but then that makes negative 77. So,
Yes.
Yeah.
That is an issue. That's why your signs were flipped.
Yeah.
I bet you got the exact opposite.
Yeah.
So did you have this?
So it'd be like the
No,
same
you
exact
did?
thing, just like
So believe it or not, that is always a common thing, right? Like getting the positives and negatives straight. So go slow, take your time. It's obviously it's not something you're like don't know how to do. You just need to take your time and do it right. Okay, so here I am going to factor out a negative 16t. That's what's in common here. So negative 16t. The leftovers would be t minus 5. I noticed going around a lot of folks are forgetting that minus 5. Because if you divide a positive by a negative, you get a negative. So you just want to be careful with that. I'll also factor a negative out of the other one. So it would be negative 3, parentheses, t minus 5. That allows the leftovers to match. My final factoring would be 0 equals t minus 5 times negative 16t minus 3. Now we use the zero factor property, and we set each factor equal to 0. So it'd be t minus 5 equals 0. And negative 16t minus 3 equals 0. You'd get t is equal to positive 5 when you add that 5 over. And over here you'd get t is equal to negative 3/16 when you add the 3 and divide by negative 16. So in this case, just like before, we've got a positive time, we've got a negative time. You might make a false assumption here and think, oh, if it's a fraction, I reject it. That's definitely not the case. It's if it's a negative time, we reject it. So we would reject the negative number and accept that t equals positive 5 as something indicating a future landing of the arrow, and we'd be done. So, do you have any questions? I got to a lot of them walking around, seeing a lot of good stuff. Really, really encouraged. Okay, so we got 2 more we're going to do here today. If we have time, we might have 1 more, but I definitely want to cover 2 more here. So here we go. Let's check out number 5. I want to do number 5 with you, and then I'll leave number 6 up to you. But I want to talk a little bit real quick about consecutive integers and what this means. This will come into play with these questions right here. Do you guys know what the word consecutive means? In a row, continuously, back to back, right? Yeah. So consecutive numbers would be like 1, 2, 3, 4, 5, ... Those are consecutive integers. But then we're going to sometimes be working on these questions in which we have some unknown integers. So it's not like 2, 3, 4, 5. It could be 77, 78, 79. I mean, we just don't know. So we need to have a way to, bless you, set those up. So if I have consecutive integers and they are unknowns, that's going to be a variable. And I would say that the first integer would just be like an n or an x or something. It'd be a variable. So if the first integer is n, what would be the next consecutive integer?
n plus 1.
N and 1 more, right? Because that would be the next one up, so it'd be n plus 1. Good. And then if maybe we had 3 of these, what would be the third integer? N plus 2, and a fourth one would be n plus 3, ... It could continue on for as long as we need it. And then, of course, that's because the spacing between consecutive numbers is 1, right? We could also have consecutive evens or consecutive odds. So what's the spacing between consecutive evens and odds? It's 2, right? So the distance between 2, 4, 6, 8, 10 each time, the distance is 2, isn't it? But same thing with 1, 3, 5, 7, 9, the distance is 2. So if we had consecutive evens or consecutive odds. The first one was n. The second one would not be n plus 1. It would be n plus 2, right? Because evens and odds are 2 apart, whereas consecutive integers are just 1 apart. What would the third one be? N plus 4, and then n plus 6, dot, dot, dot. So you want to keep that concept in mind as we work on these. I'm going to do number 5 here with you, and then I'll leave number 6 for you guys to try on your own or maybe with a partner. So take a look at number 5. It says the product of two consecutive integers is 272. What are the integers? So what are some... I think someone's just pushing something down the hall. What are some keywords you see here that might help you understand what to do? Product. What does product mean? Multiply. So maybe you underline it. Maybe you just write the word multiply above it or something. So the product or the multiplication of two consecutive integers. Two consecutive integers. That's some other key words there. So let's set those up. If these are consecutive integers, one right after the other, we have no idea what they are. They're variables. The first one would be n. So I'll just put first integer is n. What would the second integer have to be?
N plus 1.
N plus 1. So then what is it that we do with these? It says the product. It's multiplication, right? So if I take these two consecutive integers and I multiply them, I would get this, n parentheses, n plus 1, right? So that's me taking one of the integers times the other, or multiplied times the other integer. And then there's one more keyword. It's the smallest word in the whole thing, or well, one of the smallest words. Is. What does is mean? Is means equals, so we would say equals 272. Okay, so this might kind of look like something we haven't done before, but do you see one little step that we could take that might do something helpful? Distributive property. Okay, I agree. So n times n is what? N squared. And of course, n times 1 is just n. So n squared plus n equals 272. Is this starting to look a little more familiar? Look like one of those quadratics, kind of? But it's not in standard form, is it? Let's subtract that 272 over. So it'd be n squared plus n minus 272, and now equals 0. Now it's in that standard form that we've been practicing with so much. So it's a trinomial, it's a quadratic trinomial. So we got to figure out how this works with our x, and we'll try to split the b up. So my AC would be negative 272. And what is my b? 1. Huh. Wow, this is, negative 272 is a pretty intimidating number, isn't it? But they have to differ by 1, right? Because you got negative 272, yet we're supposed to add them up and get 1. So let's think this over. I mean, it's going to have to be like 10 times 11, right? Is 10 times 11 good enough? No. 11 times 12, 12 times 13. Do some work on your calculators. Let's figure this out. Which two numbers multiply to be 272? And we'll figure out the pluses and minuses here in a second. What do you think? 16 to 17? You guys agree? Yes, good. Okay, so then should it be negative 16 or positive 16? It has to be a negative 16 and then multiplied times a positive 17, because they need to add up to be a positive 1. So we split up our b using those numbers. Nice work, Braden. I'd say that you have made some progress from a few minutes ago. That's good. So minus 16n plus 17n minus 272 is equal to 0. And then hopefully these steps are just feeling really familiar at this point. That would be a good thing. You group and you add the groupings. The GCF is n, so I end up with n minus 16. What's the GCF on the 17n minus 272? 17. Yeah, if you were doing the multiplication earlier, maybe you'd recognize that. So it'd be plus 17, and then it would be n minus 16 for your leftover. At that point, I would snake my way back up through here and write n minus 16 times n plus 17. Sorry, I'll try to be entertaining. Equals 0. Oh, my equals 0 fell off the page.
Sorry, I didn't mean it like that.
I know. Oh, you still can't see my equals 0. Let's do this. Sorry.
I just feel like, what?
I was just thinking about the folks watching the video being like, what was that? Okay.
Oh, you're recording?
I'm recording this right now. So then, you guys aren't. I usually only record you guys on Fridays because you guys are the first class on Fridays. I usually take my shot with the recording on the first class, and it usually works out just fine. But I always have you guys. Since you guys are normally second, I always have you like if I mess up the video on the first class, I can always do this with you guys. And I've done it a few times, but usually it works out okay. Okay, so we end up with this. Did you guys get n is equal to 16? N is equal to negative 17?
Yes.
Okay, so I've got two sets of numbers here. I've got 16 and negative 17. Look back over here. It says the product of two consecutive integers is 272. What are the integers? It doesn't really say that the integers have to be positive or negative, right? They really could be either. Sometimes you'll be restricted to they have to be negatives or they have to be positives. Here, it gave you a lot of freedom. And so I would say I've got two sets of them. I know the first one is n and the second one is n plus 1. So here would be my two sets. I would say it's going to be 16 and 17 using this one, or negative 17 and negative 16 using that one. So I'd have two sets of integers that would work here. Does that make sense or no?
No.
Darn. Okay. So hold on. Before you get frustrated or anything, let me try to explain.
In the end, this is still positive. Got it.
It just said, yeah, product is 272. So I got two answers, right? I got this answer right here. I got this answer right here. So if I just take this answer, n equals 16, you remember how I set up my integers where the first one, it's over here on the left, the first one is n, and the second one is n plus 1, right? So if n is 16, that means the first would be 16, and if the second one is n plus 1, wouldn't the second one have to be 16 plus 1? 17. So there is one set of numbers that works right there. But haven't I totally ignored the negative 17 that I also found? Yeah. So I could also get a set of answers there. So the first one would be negative 17. And what is negative 17 plus one more? Negative 16. And so that would be, we could get two sets of answers. Either, we have both. Both of them work. So let me take questions. Deacon.
So this might be like really stupid, but why go through like the whole trouble of factoring
Yeah.
and stuff?
Well, you can just guess and check.
Yeah. Well, like, because you did the X thing and the 16, 17 right there. So
Oh, yeah. So you're recognizing kind of a cool pattern. So did you notice on this one, when we set up the quadratic equation, we got to like right here, and that's like the time when we set up the x and the ac and the b and all that stuff. Did you notice that the a value is 1? So when the a value is 1, the pattern that you're recognizing is dead on. Okay, you can just factor it straight from there. But when the a value is not 1, you gotta go through the whole process.
So
Yep.
like on a test, if the a value is 1 and we like did the X and got it, but you still have to like.
Can I just be totally, completely straightforward and upfront with you? When it comes to factoring, like the step of going from something that's not factored to something that is factored, I don't really care if you show any steps. I really don't. Like if you, this is going to sound weird, and I'm not saying this, don't mishear me. I'm not saying this about this question as a whole, but I'm saying on the factoring step, if you can just go like in your head, okay, this multiplied by this, and oh, that works, that's fine. In fact, I would love it if you could do that. If you can't do it, that's fine. You can go through the process. But so the answer to your question is I don't think you'd have anything to worry about. Yeah. Was there one more question maybe I thought I saw? No? Oh, yeah, Kinsey.
Like both answers would work on the...
Both sets of answers, yep.
You have
So-
to have both?
Yeah, so both sets of answers work, so yes. I'll tell you what, let's contrast this a little bit for our last one, just to give you a sense of what it could look like if maybe you'd only give one set of answers. Okay, so take a look at number 6. You can see number 6 is similar enough to what we just did, but just in interest of kind of helping you understand the whole two sets of answers thing, hey, please check this out. So if I said the product of two consecutive what if I inserted the word positive right there? Let's say I rewrote the question a little bit. So the product of two consecutive positive integers is 168. What are the integers? Now this would change things a little bit as compared to the previous question, right? So should set up the same way? No? Did I lose you somewhere? Sorry?
84. Could be the numbers.
Don't do the guess and check. Yeah.
Sorry.
So I thought Deacon was kind of going there, but he wasn't really going there. Let's talk about that. It's entirely possible that a person with a calculator, because these are integers, right? It's so possible that a person with a calculator could sit there and just like do some multiplying and do some figuring and they could come up with this. I just want to be, listen, I want to be super clear with you. Since this is in algebra class, I want to see that you have used algebra to arrive at an answer. So if you guess and check right, and you're like, this definitely works, be prepared to receive far less than full credit, okay? I'm going to want to see that you actually set up an equation. I want to see that you actually solved that equation as opposed to, I'm a pretty good guesser and checker. I want to see that you can actually do algebra. It's an algebra class, right? So please, please don't say, yeah, I'll just guess and check. You can do that. You just won't get anywhere near full credit. So I just want to be clear about that. Rosie? It doesn't work?
It's 14 and 12, but they don't add up to be 1.
Oh, really? I wonder if there's they don't add up to be 1?
It adds up to 2. Like on the X, the
So you're saying, I don't know, I hope there's not a typo. If there is, we can fix it. Let's check it out. So did you guys set up your integers? Your first one would be n, and second one would be, I wonder, let me think this through. Hang on. So you're getting n squared plus n minus 168?
Yeah, and we
You
have
go like this.
If hang on, if your b was 2, would it work?
yeah.
So I think there is a typo. This will work out. This is actually going to work out really good. So let's change this a little bit. I apologize. There very well could be a typo. Let's fix this. Let's say that it says the product of two consecutive positive even integers is 168. This might be what it should have been. So then if that's the correct description, we'd say the first is n and the second one is n plus 2 because the spacing between evens is 2, not 1. So maybe run with it from there and see if that works. If that's the case, I apologize for the typo. I think it illustrated a pretty good point unwittingly if that's the case, but appreciate those of you that worked on that and maybe figured that out. What's wrong, Sarah? What part don't you get?
Like everything.
Oh, please don't say that because you've actually been doing really well today. Be realistic. There are some things you are getting, and there are some things you aren't.
I don't get the end part.
Like how we're setting it up.
Yeah.
So it says that there's two consecutive positive even integers, and these are total unknowns. So in math, if something is a complete unknown, like we have no idea what it is, we usually use a variable for it. And so I know that these are two consecutive positive even integers. So the first integer is like totally an unknown. So I'm just going to be like, I'm going to call it x, or I'm going to call it n. It's just going to be a totally unknown number, right? But I do know that the numbers are even. And so I know that if one number is n, then the next one up would be 2 away from it, right?
Oh, one of them has to be negative.
And so the second one would have to be the original one, which is n plus 2. So then just like before, I know that the product of those two is 168. The product means multiply, and so we start to multiply. So it should be real similar to the first one, isn't it?
Yes.
Oh, so n squared plus 2n, make that a 2 minus 169.
It's a positive even.
Positive and even consecutive integers. So it worked out okay? It must have been, you must have left off the word even. Okay. Let's try to wrap this up real quick. As you guys know, product means multiply, so it would be n parentheses n plus 2, and is means equals 168. Hopefully you're seeing a lot of similarities between this one and the other one. Here you get n squared plus 2n equals 168. Please don't pack up yet. Still got time. Let's finish well. You subtract the 168 over, you get n squared plus 2n minus 168 is equal to 0. And then your x tells you that you've got negative 168 and 2. And you guys came up with 14 and negative 12, right? Okay. So, using Deacon's pattern, I don't know if this is okay. I hope it is. You can actually just jump straight to n plus 14, n minus 12 equals 0. You can go through the whole split the b thing, but because n was 1, the pattern that Deacon noticed is good. So you end up with n plus 14 equals 0, n minus, please don't pack up. I know I've got about a minute and a half, 2 minutes left. Then you end up with n equals negative 14, n equals 12. Here's where I wanted to finish with this. Wow, please don't pack up. That actually means, please don't pack up. I told you that they had to be positive, even integers. And of course, both the negative 14 and the 12, they're both even, but only one of them is positive, right? So based on that description, wouldn't we reject this one? And we'd say, all right, n equals 12 works for us. So the first one would be 12, and the second one would be 14. So those would be your two consecutive, positive, even integers. Sarah?
So would the directions have the positive, even?
Yeah. So like I put those in there, but if I expected you to do that, I would put those in the directions. Yep, for sure. Okay, practice up. We got a quiz on Monday, and so be ready to roll. Have a great weekend.